Alright, I thought I would do a tutorial on how to draw an enantiomer. I've sort of done this in class. I've done it kind of fast. There are really two ways of doing it. So let's take one you haven't seen yet. Well, you might have seen this one. Alright, so there's a molecule. You could name it. It's going to be a pentanol, 1, 2, 3, 4, 5 carbon longest chain. OH on the 2, a methyl on the 3. So what would this be? It'd be 3-methyl, 2-pentanol. Okay, so draw the enantiomer. Hit pause and draw the enantiomer. Okay, so you're back. There's two ways of doing this. There's two easy ways of doing this. You know, the molecule has a lot of sigma bonds. There are a lot of different conformations that can rotate around. You know, the enantiomer of this molecule, like this molecule itself, can look a lot of different ways. But there's two easy ways of getting to the enantiomer. One is to draw this sort of hypothetical, imaginary mirror plane. And you're going to reflect this. And when I do this, so I've just done it quickly in class, but you basically just start with the atom that's closest to the mirror, the hypothetical mirror, and draw going to the right. You draw the molecule going to the right, what you read to the left. So let's start with this methyl. Then it moves to that CH2, then to the carbon with the methyl. Okay, put that in. When you reflect in the mirror, it's not going to, you know, that carbon being back, it'll still be back. And then the carbon with the OH, and it's still going to be out. And then the methyl. So you draw to the right what you see going to the left. So we start here, and then sort of transcribe this molecule, but transcribe it the other direction. All right, that gets you the mirror image. That gets you directly the mirror image, and now you can see that they're non-superimposable. If you take this molecule, turn it over, and slide it over, the two-dimensional framework overlines exactly. So the 5-membered, or the 5-carbon chain overlaps, the methyl overlaps, and the OH overlaps. But the OH, if you turn this over, that OH which is sticking out at you will go back. The methyl which is back will come out. And so, even though in 2 dimensions they overlap, the OH, this OH would be out. The one you're trying to overlay, the OH would be behind. This methyl is back. The methyl you're trying to overlay would be in front. So they're non-superimposable mirror images. They're enantiomers. So you've successfully drawn the enantiomer. Wonderful. What about the second method? I said there were two easy ways. Well, the second method is to just draw exactly the same molecule. Draw it in 2 dimensions. All right. There's nothing there. Okay, sorry. So there you go. This stick figure looks like that. Looks like that as well if you turned it over. So now that you've got all the atoms lined up, so you want to line up all the carbons, all the substituents, you want to make it look exactly like the first molecule. Then when it looks exactly like the first molecule, minus the stereochemical information, invert each chiral center. So instead of the OH being in front, it would be back. Instead of the methyl being in back, it would be in front. And in fact, that is also an enantiomer of the original molecule. And you can satisfy yourself that this is the mirror image of the first molecule. Pick it up, turn it over. The OH, which is back, comes out and moves to the right. The methyl stays on the middle carbon, but when you turn it, it goes back, and you have that structure, which is the mirror image. All right, those are the two easy ways of drawing an enantiomer.